Okay students, in previous chapter we studied about Coulomb's law and Coulomb's law in vector form. Today we are going to study about electric field. Electric field, it is the region around the charge. It is the region around the charge in which any other charges will experience the force. Let us consider there is a charge, source charge. Okay, around this charge there will be a region. Around this charge there will be a region where electric field will exist. This region will be depending upon the magnitude of the charge. If any other charges will enter this region, this charge will experience the force. This charge will experience the force. Okay, now by experimentally we have found that when we increase the magnitude of the charge, the force experienced by this charge is increased. Okay, similarly when we increase the electric field by any method, the force experienced by this charge is increased. Hence, the force is increased when electric field is increased, and the force is increased when magnitude of the charge is increased. Hence, we got the equation that F is equals to E into Q. Okay, now here E is the electric field, so E is equals to F divided by Q. Hence, by the formula, we can also define electric field as it is force per unit charge. It is force per unit charge. Electric field can also be defined as it is force per unit charge. Okay, and it also defined as it is the region around the charge in which any other charge will enters, then it will experience the force. This, if both the charges are of like charges, then this charge will experience repulsive force. Okay, if these two charges are unlike charges, then this force will experience the attractive force. Okay, and by experimental methods, what we found, when we increase the magnitude of the charge, the force is increased, and also when we increase the electric field somehow, then the force is increased. Hence, we get F is equals to E into Q. Therefore, E is equals to F by Q. By this formula, we can define electric field as it is a force per unit charge, and by this formula, the SI unit of the electric field becomes Newton per Coulomb. This is one of the electric field. There are some other SI unit of the electric field. We are going to study them further. Okay, this is about the electric field. Okay, while studying about the electric field, we are going to represent this electric field in a geometrical form, and that is called as electric field lines or lines of forces. Electric field line or lines of forces. Okay, this electric field, while studying, we are going to represent this electric field line, the representation of electric field in geometrical representation. The geometrical representation of electric field is called as electric field line or lines of forces. Okay, now we are going to study about the properties of these electric field lines. Properties of these electric field lines. Okay, now properties of electric field lines. And friends, the electric field is a vector quantity, and we are going to show the direction of the electric field by the properties of the electric field lines. While studying the properties of the electric field lines, we will come to know how the direction of the electric field is drawn. Okay. Now, the first property is the electric field lines. The electric field lines starts from positive. They will start from positive and ends at negative, or we can say that they will terminate at negative. Okay, they start from positive and terminate at negative. It means suppose there is a positive charge and there is a negative charge. What happens? The electric field lines, they starts from positive and ends at negative. They starts from positive and ends at negative. And second one, these electric field lines are perpendicular. These electric field lines are perpendicular to the conductor or conductors. It means, suppose consider there is a conductor in this shape. How the electric field lines will enter or emerge? These electric field lines will be shown like this, perpendicular to this conductor. Perpendicular to this conductor. Similarly, like the brush which we use in washing the test tube. Okay, this is similar like the washing the test tube brush. Okay, or if the conductor is like a sheet, then the electric field lines are always perpendicular to the conductor. It is always perpendicular to the conductor. It is like a polishing brush, shoe polishing brush. It is like a shoe polishing brush. It is like a test tube washing brush. Okay, like this, the electric field lines are shown. Okay, they are shown always perpendicular to the conductors. Next, they never intersect each other. Two electric field lines will never intersect each other. Okay, it means two electric field lines, the two electric field lines will never intersect like this. I will tell you why two electric field lines will never intersect in the next property. Okay, the fourth property is the tangent drawn to the lines of forces shows the direction of electric field at that point. The tangent drawn to the lines of forces shows the direction of electric field at that point. It means if I will draw the tangent at this point and at this point, this is the direction of the electric field. Similarly, at this point, if I draw the tangent, then this will be the direction of the electric field at that point. Similarly, if I draw tangent at this point, then this will be the electric field at that point. Okay? Now, I will tell you why two electric field lines never intersect each other. Okay? Look at this. If two electric field lines intersect at each other, at this point, if I draw tangent, there will be the two directions. That means if I kept any charge here, then it will move in the resultant of these two. It will move in the resultant of these two, which is not possible. It means why two electric field lines will never intersect each other? Because at a point, two direction is not possible. At a single point, two direction is not possible. Hence, they never intersect each other. Next, the intensity. Intensity of the electric field is maximum when they are closely packed. And intensity is minimum when they are loosely packed. Okay. Now look at this. If the electric field lines at this particular area are more. So here the intensity of the electric field is maximum. If I keep the same area here, now the electric field lines are less. Here the electric field lines are more. Hence, intensity when compared to here will be the intensity is maximum, here will be the intensity is minimum with respect to each other. Okay? When I compare these two areas, let us consider these two are the similar areas. Okay? These two are the similar areas. When I consider these two areas, here the electric field lines are less, here the electric field lines are more. Hence, here the intensity of the electric field is maximum, here the intensity of the electric field will be minimum. Hence, the intensity is maximum when they are closely packed. Similarly, intensity is minimum when they are loosely packed. Next, they contract longitudinally. Okay, look at this. How they contact? Here is the positive charge and here is the negative. They contact longitudinally. You can see this image. How they are contacting? They are contacting longitudinally. And the next is they exert lateral pressure. It means if I consider two similar charges. Okay, if I consider two similar charges, from the property of first property of the electric field, they start from positive, and here also they start from positive, hence they repel like this. It means they exert lateral pressure. Okay, the electric field lines will exert lateral pressure. These are the properties of the electric field lines. Once I will repeat it once again. They start from positive and ends at negative. Always they start from positive and ends at negative. Okay. Here, let us, if I consider any negative charge, that means I will draw electric field like this. Okay. It means there will somewhere there is a positive charge. It means somewhere there is a positive charge. It is electric field lines are coming from that positive charge. We will assume like that. Okay. This is our assumption for our convenience. Next, second one is the electric field lines are always perpendicular to the conductors. Third one is two electric field lines will never intersect each other. In one more question, they will ask you why two electric fields will never intersect each other. The answer for this is when two electric field lines intersect each other at a single point, two direction is not possible. At a same point, two direction is not possible. Hence, two electric field lines never intersect each other. And the fourth one is the tangent drawn to the lines of forces shows the direction of the electric field at that point. Okay, electric field, when I draw the electric lines of forces, if I want to know the direction of electric field at any point, I have to draw the tangent at that point, and the tangent drawn at that point will show the direction of the electric field at that point. And next one, intensity is maximum when they are closely packed, and intensity is minimum when they are loosely packed. Okay, when the electric field lines are more, then the intensity is maximum. When the electric field lines are less, then the intensity will be minimum. And they contract longitudinally. How they contract? They contract longitudinally. And they exert lateral pressure. Okay. Now, if there is a ideal positive charge, and there is an ideal positive charge and an ideal negative charge. Okay. The lines of forces, electric field lines, are drawn radially outward. The electric field lines are drawn radially outward. This is the representation of the positive charge. Electric field lines are represented like this for a single positive charge. Similarly, if there is an ideal negative charge, the electric field lines are radially inwards to the positive charge. The electric field lines are radially inwards. Radially inwards. Radially inwards. In positive charge, in ideal positive charge, they are radially outwards. Electric field lines are radially outwards. Here they are radially inwards. Radially inwards. If there is a dipole, dipole means two small charges, two equal and opposite charges separated by small distance. We are going to study about the dipole in later. Okay, if two charges, unequal charges, then the electric field lines are drawn like this. Means like this. The electric field lines of dipole is shown like this. This is the electric field line of a dipole. Representation of electric field line for a single positive charge and a negative charge and a dipole. Okay. Further we are going to study next class.